everyone, and thank you for coming to this session this afternoon. I know it's the last one, so thank you for bearing with us. My name is Jess Modini, and I'm a senior technologist at AWS. I'm joined here shortly by Xavier Hutchinson. He's one of our senior solutions architects. We're both here from Australia. Today, we're going to be talking about cyber threat intelligence. We're going to step through what is cyber threat intelligence, why should you care about it, why should you do this? We're going to talk a little bit about how it works using an Australian case study, and then we're going to give you some key steps for getting started on AWS. So, what is threat intelligence? Wouldn't be a PowerPoint presentation unless we did some kind of definition, right? Cyber threat intelligence is threat information that has been collected and evaluated. So it's evidence-based data that you can use to inform your cyber defense. It often includes information pertaining to things like actor attribution, tactics, techniques, and procedures, motives, targets, and you can also add in things like commentary, as well as things like certainty scores. So you might say that you are 80% certain that this URL is associated with APT28, which is an actor attribution. And why should you care? One of the main benefits of cyber threat intelligence is that it allows you to stay ahead of potential threats. So by sharing information about known vulnerabilities and attacks, you can take proactive rather than reactive measures to protect yourself or your organization. So this prevents you being in the front page news, costly downtime, and of course, things like reputational damage. Another important aspect is the ability to respond quickly to emerging threats. So by sharing information about ongoing attacks, you can deploy countermeasures in a matter of minutes. This helps minimize the impact of an attack and of course further damage. Now I just want to make it really, really clear, when we talk about cyber threat intelligence, we're not just talking about indicators of compromise or individual observables. Sure, that's part of it, but they're just an ingredient. The idea is that it's about detecting threats in your environment and within your trust community, and it's about building up that common threat picture together with things like TTPs, as well as your threat information, other knowledge, open source, and of course your core data. So when we pull all of that together, we get knowledge. You've probably heard security sayings like, security is everyone's responsibility, and security is job zero. It really is a team sport. It's about communities working together towards herd immunity. And I use the phrase herd immunity. My PhD research is actually in cyber epidemiology. And if we look at how we band together in a case like COVID, where there's a huge national health disaster, we share information with each other, we take the right precautions, like wearing masks and social distancing, to make sure that as a community, we are all protected. Cybersecurity is very much the same. No single organization can mitigate these threats on their own. So I talked about trust communities. They're the way that you can build up your threat picture. So let's talk about that. They're typically formed around sectors. Now there's a huge emergence of critical infrastructure sectors around the world, and I'll talk about that in the regulatory context shortly. But one example is the financial services sector. So they've actually formed a community, a trust community that they call an Information Sharing and Analysis Center, also referred to as an ISAC. The point here is that these organizations have similar assets, right? Think of all of the big banks. They've all got very, very similar systems, similar customers, they do the same thing. So they're likely to be susceptible to the same types of vulnerabilities across people, process, technology, and supply chain. So it makes sense for them to band together, right? There's a lot of similarities there. So by forming trust communities, ideally within your local sectors, you can share cyber threat intelligence that is sector and context specific. And that helps you identify things like context and then therefore priority, right? For any analysts here today, I'm sure you've got a long laundry list of cybersecurity things that you need to do for your environments, and it's kind of hard to identify which ones are the top of the list. The cyber threat intelligence data can be directly actioned to have a defensive impact in near real time, especially if we have that context and knowing what to do. Now, cyber threat intelligence has a life cycle. Step one in the life cycle is around terrain planning. So this is really having a look in your environments, in your organization, and understanding what are your assets, what are your crown jewels. And I know we talk about this a lot, but it really is step one. I have so many customers that talk about logging and monitoring, but they're not even sure what assets they have in the first place, what they're trying to protect. The next step is collection and situational awareness. So this is about understanding what visibility do you need based on your assets and based on those threats. So when I explain this to my mum, I explain it like protecting her house. It's where she needs to put her cameras so that she's got the right visibility and she knows what's going on to start making an informed decision. That brings me on to the next step, which is processing and analysis. And this is what you do within your organization, but again, within your trust communities. And that's how you can use context to get data into intelligence. Next, we need to be able to do something with it, whether that's sharing across internal teams or out to your trust communities. Then you need to do something about it, so it needs to be actionable. So if we do this life cycle well, we have 3 key results here. The first is that we generate high quality CTI that is relevant. Now, I live in Australia. I live in the capital called Canberra in a suburb called Garran. And within my neighbour community, we have like a Signal chat group and we'll share information with each other. Normally it's stuff like, oh, the postman left the package somewhere else, who has it? But often it's about threats. We recently had a few break-ins to cars within the community. So we were sharing information like, oh, hey, I saw something on my camera footage, someone who was 6 foot tall wearing a blue t-shirt. Someone says, yeah, my car was broken into at 9:56 p.m. It was a black Camry on Cuvier Street. So we start to build up that threat picture together, right? It's about that local context that makes that directly relevant to me to know if I want to park my car on the street that night or whether or not I might want to park it in my garage, which I can't always be bothered to do. If I was added to a Signal group for some Sydney suburb, I don't know, I'm not sure that would be too useful for me. It might give me some macro trends around crime in Australia, but it's not going to help me make an informed decision about what I do with my assets that night. Next, we have rapid sharing. So we can use machines, we can use our computers, and we can use our technology to make sure that this happens fast. Back in the day, it used to be written on a napkin. You used to have to, quickly text a fellow CTO or CEO for a quick coffee and go, oh man, we're seeing this stuff on our network. What are you seeing? By setting this up the right way, you can make sure that this is machine speed, which is really, really important given how quickly the cyber threat moves. Thirdly, the intelligence should be actionable. High quality cyber threat intelligence will have some kind of action that tells you what to do with it. So here's a bad IP address, it's associated with this actor, and you should block it. With what tools? That tells you exactly what you can do, rather than just a long list of things that you need to actually go in and look at. So I want to just talk a little bit about the regulatory context here. I think it's fair to say that doing cyber threat intelligence is a good thing to do for your environments, but we're certainly seeing a shift in the legislation towards cyber threat intelligence sharing globally. So this is a bit of a snippet. In the EU, we have DORA. DORA is the Digital Operational Resilience Act. So it encourages cyber threat intelligence sharing among financial entities within the EU. It doesn't mandate it, but it certainly encourages it. It looks at things like IOCs, TTPs, security alert reporting, and configuration tools, and sharing that across the community towards operational resilience. We also have NIS2 in the EU. So that is the Network and Information Systems Directive 2, which takes a really significant step forward compared to DORA regarding cyber threat intelligence sharing. While DORA encourages it, NIS2 actually mandates it under certain conditions. And this seems to be the direction that a lot of the legislation is heading towards. NIS2 compels what they call operators of essential services, so critical infrastructure operators, to report certain cybersecurity incidents to relevant authorities. These reports often contain valuable threat intelligence that can be shared with other operators of essential services. So this is all about moving towards collective defence. In Australia, we have a thing called SOCI. It's the Security of Critical Infrastructure legislation. It's just been renewed over the last year or two, and it's actually expanded out critical infrastructure sectors. We now have 11, which is really, really cool, and a lot more fidelity around what is the sector, what is an asset, and what are the crown jewels, which we call systems of national significance. The goal of that legislation is to create an environment that fosters collaboration. So it's all about bringing these sectors together and kind of bringing down any of the barriers towards sharing information and intelligence with each other. Now, the US is a bit of a tricky one. There isn't like a single piece of legislation or law that mandates cyber threat intelligence across the board, but the Cybersecurity Information Sharing Act, or CISA, certainly goes towards encouraging it. It provides liability protection for private companies when they share information with government. So again, it's a good way to incentivize private industry to collaborate with government without the fear of things like legal repercussions. We also have the Department of Homeland Security that has various programs that encourages things like bidirectional threat information sharing, like the Automated Indicator or AIS sharing program. This program allows all of these organizations to share things in a secure manner using standard protocols, and we'll get into that in a little bit more detail. And again, it's not mandatory, but it's certainly moving towards incentivizing this sharing. All right, so you're probably wondering, how does this actually work? Let's step through this. The Australian Cybersecurity Centre is the Australian government's lead agency for cybersecurity. And they have this thing that they call the CTIS program, Cyber Threat Intelligence Sharing. I'm sorry how many times I'm saying cyber threat intelligence, but bear with me. It's a key initiative of the Australian government's cybersecurity strategy. Now, the goal here is to create a platform where industry and government can collaborate together on sharing cyber threat information. And it means that they can do it, again, machine speed, so that they can be best positioned to identify and respond to threats. The ultimate aim here is improving the resilience of Australia's digital economy. The CTIS program was co-designed with industry following extensive workshops, like weeks and months of workshops, for requirements gathering to make sure that it was actually going to be useful within the regulatory, legal, and technical contexts of industry. So there's a lot of lessons learned in how they've kind of put this together and the best way to do things. It's built on industry standard formats. For those of you familiar with cyber threat intelligence, you might be aware of MISP and STIX, which are two data formats, and TAXII, which is the transport protocol for it. So they're essentially building blocks for the interoperability to make sure that sensitive or even classified information can't accidentally be shared out. So if you're sharing something that you found in your environment, you're not accidentally going to release, some of your customer PII, which is pretty important, right? And that's part of the initial fear back in the day. At the core, cyber threat intelligence platforms partner with industry so that they can share threats into the Australian Cybersecurity Centre. The ACSC then enriches that. So for those of you unfamiliar with the ACSC, it's actually a group of the Australian Signals Directorate, which is the Foreign Intelligence Agency. So they've got some special sensors and special things that they can't tell us about, but they can certainly enrich and validate intelligence and then share it back out. The ACSC CTIS platform is built on AWS. So it helps them to automate and scale nationally and internationally, especially across the Five Eyes community. Now let's step through a bit of an example of how it actually works. An ACSC analyst can receive intelligence either through the CTIS program and platform from other partners, or maybe they discover something malicious using their own tooling. In one particular case, an analyst identified a URL which was aiming to mimic Australian government infrastructure, specifically a website that is used for social services. So something pretty important where, thousands of Australians access that website every single day. They did a bit of analysis, and it was identified that this URL was hosted outside of Australia. They confirmed that the URL was malicious, and then they fed that indicator of compromise and some of the other contextual factors out to all of the partners within the CTIS community, which meant that they were able to protect their infrastructure. So they could make sure that all of their customers and employees weren't clicking, resolving to that URL, and accidentally inputting their credit card details, which could be used for cybercrime or passed on. The ACSC was also able to issue a takedown request to the infrastructure hosting provider to, again, protect more Australians, and they fed it into what they call their PDNS system, which is a protective DNS system, which a lot of the government and critical infrastructure operators in Australia use to protect, again, hundreds of Australian organisations. Another example, an ACSC CTIS partner reported that they had 69 IP addresses communicating with a web shell. ACSC had a bit of a look at this and they identified that the web shell was China Chopper. For those of you unfamiliar with China Chopper, it's a web shell hosted on web servers to provide access back into an enterprise network without needing to rely on an infected system. It calls back to a remote C2 or command and control server and has been used by so many threat groups over the last few years. They shared all of this intelligence out to the partners, so again, they could check their environments and make sure that they were protected. So this collaborative approach across industry and government shows the value of collective defence. The ACSC CTIS platform is something that they actually offer out to all Australians, right? So you can sign up to that special feed, but the actual capability itself, in terms of the threat intelligence platform and how it communicates, is something that you can do yourself. The ultimate goal of cyber threat intelligence is, when a new attack happens, it is analysed, it is profiled, it is turned into wisdom, it is turned into cyber threat intelligence. And that threat intelligence is shared out to other organisations at a speed that is required to block a second attack from occurring. So it's basically, we found an infectious disease and we are immediately finding a way to immunise everyone within the population, which is pretty cool. So at this point you might be wondering, okay, cool, but what does AWS do when it comes to cyber threat intelligence? We have the largest public network footprint of any cloud provider. So our scale gives us some pretty unparalleled visibility into certain activities on the internet in real time. Our threat intelligence as AWS comes from a range of things, but mostly network sensors, threat disruption, AWS network controls, and of course, cooperation with other internet players. We have recently shared a lot more information about what we do in this space, which is really exciting. And we've shared information about what was previously a bit of a secret squirrel project called MadPot. Some of you might have read about it. This is what we use to lure would-be attackers into targeting fake digital targets. This means that we can capture that, we can study it, and then we can counter their methods. Has anyone here heard of Sandworm? A few? Awesome. It's a hacking group tied to Russia. Now, Sandworm attempted to exploit a vulnerability in what they thought was a security appliance. Turns out it was MadPot. We were able to use these insights from MadPot to capture information like the IP address and other distinguishing signatures. We also discovered that one of our customers was caught in the crosshairs. So we were able to alert them and make sure that we could avert harm. So we have tens of thousands of threat sensors monitoring more than 100 million attempts each day to connect to these decoys. And these decoys are commonly referred to as honeypots. You probably gathered that from the name, honeypot, madpot, but just to clarify. And of course, all of this information informs how we fortify our infrastructure. The results from MadPot also produces updates to our security services sometimes. So we'll often push this cyber threat intelligence into products like Amazon Guard Duty, AWS Shield, Web Application Firewall, and it will also inform exploit vulnerability intelligence that goes into Amazon Inspector, for those of you who use Inspector. And like the ACSC example, MadPot also frequently sends automatic requests over to internet hosting sites telling them to take down customers of theirs that are malicious. For those of you who listened to the keynote this week, you might have heard about Sonaris, which is another internal tool that we are now talking about, again, very exciting, that we use to analyze network traffic, to identify and stop malicious attempts to connect to a large number of customer accounts to find vulnerabilities. There's some pretty staggering numbers around this. So between May 2023 and April 2024, so like the last year or so, Sonaris denied over 24 billion attempts to scan customer S3 buckets and prevented nearly 2.6 trillion attempts to discover vulnerable services running on customers' EC2 virtual servers. Once again, security is a team sport, and threat-informed collective defense is the goal. It moves us away from reactive defense, where you're just sitting there and you're putting out fires and your analysts are handing in their resignation letters, towards proactive defense. This is where your analysts can actually operationalize intelligence to monitor and manage environments with clear priorities that are, again, contextualized by your trust communities. Ultimately, we want to move across to what we call collective defense. So this is where your organization is collaborating on a combined threat picture, where the intelligence received is contextualized, it's actionable, to the point where we can actually automate this for near real-time defense. It also means that your analysts, are likely a lot happier with their jobs, which is what we all want. So now that I've convinced you all that cyber threat intelligence is really, really great, really, really essential, you will need to know how to get started. I'm going to hand over to Xavier now to do a bit of a deep dive on how to get started on AWS.
Thank you, Jess. And in this half of the talk, we are going to try and raise the bar a bit on our security threat intelligence capabilities by walking through on what a threat intelligence platform architecture might look like on AWS and the different integrations, touchpoints, and strategies you may leverage along the way. So the first step in enhancing your cybersecurity capabilities on AWS is to deploy a threat intelligence platform. There's quite a few industry solutions out there, but the one that I'll call out is OpenCTI, which is an open source project. And this is ideal because it benefits from greater code scrutiny and transparency from the broader community. These solutions can be deployed in a variety of ways, depending on whether you have a preference for servers or containers in your organization. You can use things like Amazon Elastic Compute Cloud, EC2, or ECS if you prefer the containers. There's also AWS Marketplace where you can use partner offerings to be able to deploy your solutions that way. Now, after selecting your mechanism for deployment and on your platform of choice, the next critical step is that integration piece with a trust community, as Jess was talking about before. Jess highlighted the importance of these communities and being a part of one. And here I'm going to make the suggestion again that not only is it good to be a part of one, you might want to consider being a part of more than one of them as well. Once your platform is deployed, you're integrated with a community and you're starting to receive your threat intelligence, you can start to extract actionable insights out of that intelligence and feed that into your security operations. The cyber threat intelligence is valuable for both intrusion detection as well as prevention services, and we're going to discuss a couple examples of this in just a moment. It's important to remember, though, that the best community members are ones that actually actively contribute back to their communities. So once you're on your feet and you've got your platform running and you start to do your own threat hunting and identifying your own vulnerabilities or indicators of compromise, please feed that back to your communities as well so that everyone benefits from your knowledge. Now, we're going to dive a bit deeper into a complete CTIS solution on AWS, focusing on prevention and detection capabilities. The essence of joining a community is to receive and share structured and actionable threat intelligence. And as this intelligence flows through your threat intelligence platform, you can set up some rather simple yet highly effective automation and workflows to ensure that that intelligence is acted upon with minimal human intervention. Let's start with an example of what we can achieve with this intelligence from the perspective of preventative capabilities. A highly effective starting point is implementing new firewall rules as intelligence about IP addresses and domain names come in. This action alone can be enough to disrupt the command and control links or exfiltration pathways of rendering any malicious actors that may be in your environment inert until you can eventually get rid of them. This is also a good opportunity to mention a couple of AWS services. AWS Network Firewall is a Layer 3 and Layer 7 firewall service that enables you to be able to define rules with fine-grained control over your network traffic. And by leveraging AWS Network Firewall, you can block single IPs, IP ranges. You can even block undesirable domain names, filtering out that unwanted traffic and internet traffic from your environment. Another call out is the AWS service Amazon Route 53 Resolver DNS Firewall, which again can be used to block further undesirable DNS queries from within our environment. It's also mentioning too that both of those services have managed lists of known or undesirable low socially scoring IP addresses and domains. And by leveraging those lists in your deployments of those services, you're basically leveraging the knowledge that Jess was just talking about before from our internal services that sort of go out there and find these actors. Going an even step further though, you could actually ingest a lot of the logging data that you get from these services. Like say for example, Route 53 Resolve DNS Firewall, you could grab early insights as to what's going on and any potential spread of malicious actors within your environment by looking at requests that have been made and seeing those black holes or rejections. As far as detective controls go, AWS Guard Duty is a threat detection service that's constantly monitoring your AWS accounts and workloads for malicious activity and delivering detailed security findings for visibility and remediation. Your cyber threat intelligence can be fed into Guard Duty in the form of IP addresses and IP ranges in the site. And Guard Duty will then scan your logs to detect any anomalies or malicious behavior within your environment, surfacing any findings that as they occur for human assessment. This means it can even actually detect zero-day threats. Now, as you receive your new intelligence or generate your own, ideally, it's crucial to leverage this information by examining your environments and workloads using logs that you have stored. Having historical logging data available and ready is essential for being able to scrutinize new indicators of compromise as they emerge and come in from your communities. You can configure your networking appliances such as AWS Network Firewall to produce VPC flow logs, which will enable you to then track your IP traffic to and from network interfaces within your cloud environment. You can also generate Route 53 Resolve DNS Firewall query logs like I mentioned before, and then you can centralize all that logging data into an S3 bucket, for example, or your own data lake if you've already got one, and then you can create a secure, durable, and isolated storage solution that can then be trusted and queried at any time. Another powerful tool from an AWS service that you can leverage to query information in such a collection would be Amazon Athena. If you're not aware, Athena is a serverless database query engine that basically allows you to be able to query files in place on places like S3 and the like. Athena enables you to be able to search through your logging data rather simply, looking for things like IP addresses, CIDR ages, domain names, any other indicators that might be a problem that there is, an indicator that might be a problem or compromise. Lastly, then you could send these findings onto Security Hub. And Security Hub is going to help you centralize those findings, providing you with a clearer and more comprehensive view of your security operations across your whole environment. Once these findings are now aggregated into Security Hub, they can then be shared on with your larger trust communities via your threat intelligence platform. We can take a look here at the steps behind an example reporting process. Firstly, we might have AWS Guard Duty automatically detecting some kind of malicious behavior. It's then going to record the details as a finding and forward it on to AWS Security Hub. We could also have our AWS Network Firewall to be configured to produce log alerts for any domain, IP address, or IP range that is denied access, and then a Lambda function can then look at those logging and be configured to automatically trigger and convert these logs into findings that can then be put into a standardized data format and forwarded into Security Hub as well. And much the same, again, with Amazon Route 53 Resolve DNS Firewall, we can configure a function to then ingest that logging data, find things of interest, convert them into a finding, and send it on to Security Hub for that centralized collation. And then once all these findings are aggregated in Security Hub in a standardized data format, it'll allow both AWS services and partner services to be able to interpret them for any kind of remediation activities. You can then configure your threat intelligence platform to invoke other AWS Lambda functions that can potentially act as, like, say, an internal dynamic CTI feed. Lambda can also retrieve new findings from Security Hub, convert them into something called a structured threat information expression, and then return, say, a STIX document, and your threat intelligence platform can then pass that on through a CTI feed. Your threat and intelligence platform can then publish that CTI to your wider trust community. These publishing actions can then be scheduled or initiated on demand by your analysts if they deem what they found to be critical enough to do so. And by having this kind of bidirectional sharing, it's going to enable you and your organization to build a more comprehensive threat picture within your trusted peer-to-peer network of experts. It's going to encourage growth as a community, and it also raises your security capabilities internally. Okay. With our basic protective and detective controls now in place, let's have a look at the next level of things, which is our logs correlation and pattern detection. When we discuss with customers what obstacles are preventing them from achieving better visibility and security wisdom across their environments, more often than not, we find that the root cause is going to be logging. More specifically, issues arising from inconsistent logging practices, unaligned data formats. We also find that customers report that their logging data is often scattered around the organization here and there, or with different business owners that are employing different mechanisms to achieve the required durability and retention goals, which then creates more fragmentation. Rarely is this logging data ever neatly organized together, and even less frequently is it stored in a consistent and predictable manner. The data formats also within each of the log types are usually vastly different, necessitating a plethora of different manual tooling and scripting required to do anything useful with them. This process might also involve actively monitoring log files and then replaying data onto other systems, doing data format translations in flight, and that's a computationally expensive process. Alternatively, it could be a nightly cron job, which means that any potential indicator of compromise that might exist in that logging is going to go unnoticed for potentially a day. Log duplication is also a very common problem. Even when the customers suspect that this logging is a duplication and we probably don't need to retain it, they will opt to retain it anyway, largely because one day maybe it will be different and there'll be information that I need in that, and if I don't start capturing that, storing it and collecting it, then I'll miss out on that potential one day in the future thing where I need the information that's in that log. Those duplications obviously carry additional costs and storage implications and whatnot, plus they just sort of muddy up the waters. So some other commonly reported issues are along the lines of securing these logging information, preventing any PII leaks into the logs, balancing any costs and security trade-offs, and maintaining compliance in general. Data lakes are a well-established solution for durably storing and centralizing and even encrypting logging data at rest, as well as in transit. But data lake alone won't solve all the other issues that we've just discussed. Now, you can create custom solutions to solve some of those other problems, but even if they did address all of the issues that you are facing, that's just yet another thing to architect, build, own, maintain, and be responsible for over time. So as a result, we recommend Amazon Security Lake to customers to help them address some of these issues. Security Lake is a purpose-built data lake powered by Amazon Simple Storage Service, Amazon S3, designed to centralize, organize, and normalize all of your security data, whether it's from the cloud, on-premises, or from any other custom source that you define. Security Lake also leverages the Open Cybersecurity Schema framework, which is a recognized open standard throughout the industry. This everything in this format makes it easier to not only utilize the intelligence stored within your security data sources, but also to feed it into other tooling and any other capability that might exist that leverages that format to further increase your operational capabilities and insights. By adopting OCSF, Security Lake allows you to continue to use a lot of the preferred analytic tools out there and platforms that you most likely already use today. And this means you don't actually have to resort to bespoke integrations, you don't have to maintain anything custom in order to integrate, and you maintain control and ownership of your data at all times. Now we're going to take a look at Security Lake in practice, and a good place to start is clarifying a couple of concepts of logs and security findings. A log is just a basic a boring record of an event, whereas a security finding is going to give you not just the event information, but additional context and insight as to the impact and scope of your resources. An example of this could be Amazon Inspector findings, which are named after detected vulnerabilities and include security ratings, information about the affected resources, and detailed remediation steps. But along the lines, and to borrow an example that Jess uses for her mum, they are a lot like cameras. And much like your doorbell camera, if you have a smart one of them on your house or something like that, an alert might be something as simple as motion detected or the doorbell was pressed. And okay, that might be useful in some circumstances, but it's pretty useless overall. Whereas a security finding might be, well, the alert was triggered, but it was triggered because I saw a person or a dog or a car. Going even a step further, here's the license plate number of that car. All that extra information along with that event makes it a security finding. So that's a good way to sort of differentiate the two. From an integration perspective, Amazon Security Lake can natively collect these security findings from many different AWS services without any heavy lifting or additional configurations on your part. I'll rattle off a couple of them, but this is not an extensive list. But some examples of natively integrating AWS services are AWS Config, AWS Firewall, Amazon Inspector, Amazon Macie, and IAM and the like. There are so many of them. Beyond this though, if there was ever an integration gap between a log producer and Amazon Security Lake, you could bridge it yourself by developing your own automated log analysis function that sends any findings from wherever they were captured from through to Amazon Security Lake. Okay, so now that we've level set events and security findings, we can take the discussion to the next step, which is securing and analyzing workloads within the AWS Security Lake. So first, we need to identify assets and potential vulnerabilities that might exist within our environment. For each of these, we need to determine any logging requirements that might be needed to give us coverage across those vulnerabilities, and then make sure that we're ingesting that logging information. We can then begin to generate findings by leveraging natively integrating AWS products that give us the coverage that we're after, as well as other AWS partner products if required. And as discussed earlier, you can also generate your own coverage for that integration as well, if need be. Just keep in mind though that when you select other products or you choose to embark on a custom integration, that a lot of AWS services and partner offerings do natively provide those security findings to Security Lake. So do a little research before just jumping in and writing some code or purchasing something that you think might work, because it might be better off looking for something that's natively integratable. Now we can work on consolidating the findings. AWS Security Hub simplifies the process of managing large volumes of findings from multiple providers and sources, and it reduces a lot of the effort required to manage and improve security of all your AWS accounts and resources and workloads. So, Security Hub also correlates findings across integrated products to prioritize the most critical ones to the surface. Lastly, we will introduce the powerful features of Security Lake. So this tool is invaluable for automatically centralizing security data from various sources, including AWS environments, SaaS providers, on-premises systems, and other cloud platforms into a purpose-built data lake within your own AWS account. Security Lake can also be used to aggregate all your data into the one place to enable you to gather events from disparate sources. So it's not just a log aggregation or foundational end-to-end sort of product. It can be used in a variety of different applications, and I'm going to run through a couple of them now. So for things like log parsing and processing, well, we've spoken about a lot of organizational challenges earlier when it comes to logging, and how things such as the log format, the schemas, the timestamps, etc., can really get in the way when it comes to timely analysis. But by keeping all your logs centralized and leveraging the normalization into the OCSF format, that common schema better enables downstream consumption of your data. As for real-time analysis and monitoring, security information and event management solutions depend heavily on logs to be able to identify security breaches, attack patterns and trends. So having all your logging data centralized is essential for such a solution, and it makes it a lot easier for that to be integrated. When it comes to application monitoring, application performance management solutions use logs to quickly identify any functional performance problems within an application, and by making this readily available and being able to leverage it in this way, it means you're able to reduce the mean time to resolve, increasing your overall application availability. For any capacity planning aspects, as system logs often indicate resource saturation and the resulting infrastructure-related bottlenecks from that, having this information readily available makes it easier to mitigate such issues quickly and allows operation teams to be able to assess current infrastructure capacity utilization and plan the future needs for the business. Storage is also kind of a little obvious, but still worth pointing out. By optimizing and consolidating your logging data, it makes it much easier to capacity plan. It makes it much easier to work out your storage needs and take advantage of bulk advanced data storage options or tiering to reduce cost while still retaining as much historical data as you need. AI Ops is also benefits. You can leverage artificial intelligence technologies and machine learning algorithms on your log data to perform event correlation and anomaly detection, as well as trend analysis. Any auditing and compliance capabilities are also further enabled, as well as once your logs are all located in the same location and they're durably stored and secured and normalized, it makes it much easier to be able to view things such as access records, server logins, and successful and failed API requests. And such records are typically required in order for you to maintain your compliance requirements with regulatory frameworks such as PCI DSS or HIPAA. Your mitigation of security threat capabilities also improves, as logging data often helps identify security threats, which is something that we will dive into again in just a moment. You can also further improve your advanced analytics and visualization capabilities, as log aggregation also helps you leverage more advanced analytic operations such as data mining, free text searches, complex regex queries, for comprehensive analysis, as well as dashboard build-outs. And this is going to be particularly useful for network operation centers or security operation centers. Finally, in addition to centralizing all your event and logging data, Security Lake also enables capabilities such as streaming analytics detections, time series analytics, user and entity behavior analytics, security orchestration and remediation, and ultimately just improves your overall incident response capability. Okay, so now that you have centralized and aggregated your logs and you've established a basic search capability, you're in a good position now to filter out false positives in your environment. Remember, the goal is not to eliminate all false positives, as that would mean you're overtuned and potentially missing out on useful alerts. Instead, we should be aiming to reduce false positives to a point where we're still detecting malicious behavior. We're just not getting as many of the false positives. And once you've hit that low false positive rate, you can start to investigate things such as automated ticket creation or some kind of automated response to bring a human analyst to then look at those alerts rather than having a human analyst investigate every potential threat. Developing your own analytics for log correlation is also now something you can achieve. You can use existing information and receive cyber threat intelligence to run queries over your log sources, ideally organized in a time series format for pattern detection across different phases of the attack lifecycle. So an example might be, now that you've got all this logging data and it goes all the way back to, say, a year ago, you might be able to identify the reconnaissance activity that happened all the way back when and map that to initial access activity that might have just happened yesterday. Okay, so this brings us to what's called the pyramid of pain. It's a visual representation of the different types of concerns that we may have and their ever-growing complexity to detect and defend against in our organizations. Searching for individual indicators like hash values, IP addresses, and domain names, pretty simple and easy activity by itself. But at the other end of the scale, things get a lot more complicated. When it comes to, say, hunting for TTPs is a much harder activity, as it requires a decent understanding of attack patterns and evasion tactics. And this is precisely why common frameworks such as MITRE ATT&CK have a whole section on defense evasion tactics. Real-world adversaries don't just use cookie-cutter attacks also. They adapt and actively try to evade your defenses, including your analytics. This is a good point to introduce another AWS service that I think that might be really useful and you may want to introduce this to your threat hunting toolchain, and that's Amazon SageMaker Notebooks. Now, SageMaker Notebooks are fully managed notebooks in Jupyter Lab for exploring data and building machine learning models, which is exactly the right kind of tool for your threat hunting analysts to be leveraging to do their work in a highly reusable and human resource scalable format. By leveraging Amazon SageMaker Notebooks, you can create self-guided, self-documenting, prescriptive playbooks for your analysts to use to search across your security lake for indicators of compromise. These notebooks can then be shared throughout your teams and iterated upon over time, and as new analytics or techniques come into scope. SageMaker Notebooks are additionally an ideal choice for fostering the incorporation of machine learning into your threat hunting activities. As your teams and technical capabilities grow, they're going to be able to start leveraging machine learning capabilities within their notebooks to be able to perform what was manual detection work. They're now going to be able to automate it. You can provide these investigative environments to your analysts too in a way that separates your analyst from your security lake. So SageMaker Notebooks leverage IAM permission set under an IAM role assigned to that SageMaker notebook, and providing the analyst with the right level of access to achieve their objectives, but doing so indirectly without having to unnecessarily give the analyst too much privileges. This not only helps ensure that your compliance objectives are achieved, but also ensures that the analysts are always provisioned with the right level of access to achieve their goals. Now, using Amazon SageMaker Notebooks means that your analysts can also move from performing manual searches for threats, which is what Jess described earlier as a reactive defense. Instead, they can start to conduct correlation and use automation to scale pattern detection towards a more proactive defense. And again, as Jess mentioned earlier, if patterns are detected and shared into a trust community, then we're going to end up achieving what's called a collective defense. The next step from here is testing and iteration, and one way of achieving this is through attack emulation and testing your playbooks with real-world keystrokes. You can do this by dividing up your team into say red and blue teams, where you can test your detection analytics against an emulated adversarial threat informed by real-world threat intelligence. Such an example of this kind of team engagement might be, say, you want to detect credential dumping activities, leveraging a well-known tool called Mimikatz. So you might take your red team and challenge them to use Mimikatz somewhere in your environment to dump credentials out, and then your blue team has to detect it and try and stop it. And because your red team is particularly crafty, straight off the bat, they're going to do a really simple but effective modification, and that's recompile Mimikatz as Mimidogs. That'll immediately break any detection analytics that have been previously configured that only look at the file's executable name or thread name. As this minor change, even though this is a minor change, the red team has been able to then successfully break that analytic. So in response, your blue team may now create a new detection focusing on, say, the granted access bit mask. So when Mimikatz accesses the Windows process responsible for enforcing security policies on Windows systems, it will detect permissions requested and use that as a mechanism to find the Mimikatz process. And then when your red team tries this and they realize it's not working, well, they could just recompile Mimikatz again and add some different permissions in, and even if they're not necessarily needed, that's going to break the granted bit mask. And your two teams can continue to iterate like this onwards as necessary. Eventually, you're going to be able to improve the quality of your analytics by testing them against real-world adversarial tactics, but you're also going to be skilling up your team and developing your automation playbooks. And this continuous improvement cycle ensures that your defenses stay ahead of any evolving threats. Okay, so we're getting to the end now. I'm going to give you 4 steps to take away today to hopefully be able to take a step forward when you go back to your respective roles. So step 1, pick a threat intelligence platform and deploy that to your cloud environment. There are many excellent open source solutions out there. OpenCTI is my personal recommendation, which you can deploy yourself, and remember you can find that on the AWS marketplace as well if you just want to click, go. Step 2, join a CTI community to receive enriched threat intelligence. Become an active member in those communities also. And don't forget to share your intelligence back with them. You can also encourage others to join in and participate also. Step 3, integrate with your trust communities. Consider your organisation, your sector, and any gaps in your current cyber situational awareness, and then seek out a trust community that can be mutually supportive. Trust communities often organise themselves around shared characteristics or interests, such as geographical regions, industrial sectors, business interest or threats. And many of these communities, like the Financial Services Information Sharing and Analysis Centre, also have a global reach as well. So you may not be in the exact location, but a lot of these players will be global in nature. And step 4, make good use of your cyber threat intelligence. Ensure that the CTI feeds that you receive are actionable. Integrate them with all your security products. Remember too, you can feed in logging information from your on-premises appliances as well, so don't leave them out. And then use that to automate preventative and detective controls for real-time response. This will reduce your undifferentiated heavy lifting, and it will allow your analysts to be able to focus more on the tasks that require human expertise. The more you can automate, the better, and it's going to move you from a reactive state to a proactive state and help foster that collaborative defense. That's everything. Thank you very much for coming to this session.